Can you solve this insane 6-mark vector question?
This is what we're looking at. So we're given D is the midpoint of AB and E is the midpoint of AC. Let's do some little lines to remind ourselves of this. And obviously, the CD and BE intersect at F. So we're given AB equals 2A. So, this is 2A. But we're also going to label this because we can write this part as A, because this is from here to here. Hopefully you can see that. So, we must remember to put arrows on here. AC is going to be this. BC, this. BE, this. CD is this. The reason we use arrows is because a vector has magnitude and direction. Whereas a scalar just has magnitude, we're going to need the direction, so we need the arrows. So let's find BC. Well, BC is traveling from there to there. One way we can do that is by going down here and then along here. But that's going to be going against this vector here. We see this arrow. So we're going to do minus 2a. We're going to add 2b. And we can rearrange that, of course, into 2b minus 2a. Okay, next one. B, E. Let's have a look. So we're going from here down to here. Well, we can do that pretty easily. Similarly to before, we've got minus 2a to get down to here. And then we're just going to add this half here, which is b. We've got minus 2a, add b, and we can rearrange that into b minus 2a. Nice. Let's do CD. So we're going from C to D, this line here. How are we going to do that? Well, we can go backwards here, or we can go forwards here. So we're going to minus 2b, and we're going to add a. And again, we can rearrange. Nice. So these are our answers. Should get 3 marks. Let's solve part B. So we're asked to prove that BE and CD divide each other in this ratio. So the way we're going to do this is we're going to choose a line so it goes to the point F. So let's choose this line, CF. We're going to label that lambda, where CF equals lambda of CD, and lambda is less than or equal to 1. Similarly, this line here is unknown, so we're going to label this mu, where EF equals negative mu of BE. And of course the negative because this vector is pointing in the opposite direction to what we're looking at. So we can say that lambda mu less than 1. Now we're going to find CF. So we know CD already from up here. So we simply substitute that in to get lambda A minus 2 lambda B. Now we can find CF another way. So we can say CF, we're going to go backwards here, and then we're going to go up. So CF is equal to negative B minus mu BE, which is also equal to negative B minus mu. And BE we have up here, got B minus 2A. We're going to be very careful with these brackets here because of the negative sign. So we can further expand that to be equal to minus B minus mu B plus 2 mu A. So we notice here and here we have two equations for CF, and they're looking pretty different. So what we can do is set them equal to each other. So lambda A minus 2 lambda B is equal to negative B negative mu of B plus 2 mu A. So now we can get our little highlighter, highlight the A's. There we go. And we can change the color of the highlighter, of course. Let's highlight the B's. So comparing coefficients. So comparing coefficients means everything, we look at everything times by A over here, and we compare it to everything over here. And because we're talking about vectors, this section here has to equal this section here. We're saying lambda of A is equal to 2 mu of A. And here simply we can just ignore the A because we can just cancel on both sides. Therefore we have lambda equals 2 mu. Again, well, let's bracket this. Let's say we're comparing of A. Here we're comparing coefficients of B. So what we're left with is 2 lambda is equal to minus 1, because this is here is minus 1, minus mu. So what we can do here is be careful with our negatives. Let's just times everything by minus 1. 1 plus mu. Okay? So up here we've got it in terms of lambda, but maybe we should flip around. So we've got mu equals lambda over 2. So here we can substitute in. Let's call this equation 1. Let's call this equation 2. Let's sub 1 into 2. So we're going to get 2 lambda equals 1 plus lambda over 2. Okay, now we can simply subtract this lambda over 2 from both sides. So if we're 3 over 2 lambda equals 1. 1 lambda equals 1 divided by 3 over 2. Lambda equals 2 over 3. That looks promising for our ratio 2 to 1. So now we figure out what is mu. Well, from this equation, 1, this implies that mu is equal to 2 over 3 divided by 2, which is 1 over 3. So we now know that lambda equals 2 over 3, and mu equals 1 over 3. How do we finalize our proof? So we're saying lambda here is 2/3 of this whole length. So we can simply just state that CF equals 2/3 of CD. And for mu, we can obviously 1 minus 1 over 3 is equal to 2/3. So now we can say this length here, BF, is equal to 2/3 BE. So now we can say these both imply. So the first one is going to imply CF ratio FD is the same as 2:1. And the same for the second one, we're going to have BF ratio FE. Both of them in 2:1. We can finalize our proof with this. Maybe we can say QED, maybe even a hashtag, depends what we're looking for, but the square will do. Let's just go through and check, make sure all of our things are underlined. It's nice and written proof. Okay, the vectors were underlined. Okay, here we haven't done that. There we go, there we go. Okay, there we go. This was a beautiful question, and I especially like how they've incorporated this 1/2, because as a side note over here, as far as side note, when you have a triangle, if you have any midpoints of the triangle, of any triangle, and you do the intersections of them, what's going to happen is this length here, the one going to the vertex, is always going to be the 2, and this is going to be the 1 in the length ratio. So it's a nice little trick for math challenges and stuff. And the same will happen for this. They'll always be in the ratio 2:1. So it is a really unique trick, and it works for every triangle, even scalene triangles, and of course equilateral triangles. So it's nice to know. If you manage to solve that, then you are a beast at vectors. Well done.